Good day, everyone. First of all, I would like to congratulate for the students who have participated our Hackathon Drone Challenge. So today, I would like to give briefing about the requirement of the drone and the briefing about the maps. So in Drone Challenge, individual participant is open only to primary school students aged from 10 to 18 years. Students must own a drone kit and laptop to participate. Then, medal and certificate will be awarded at the state level event. Top state level participant will qualify for the national level drone challenge. So the participant age is in between 10 years to 12 years and 13 years to 18 years. So drone requirement. Participant may use any programmable drone such as Lightbee Wing, DJI Tello or other similar models. The drone must be capable of both remote control and autonomous operation. So remind, the drone must be capable of both remote control and autonomous operation. So if you're finding other drone other than this, you have to find a drone with can do the remote control and autonomous operation. Okay, the drone must not exceed 350 millimeter length, 350 millimeter wide, and 250 millimeter height. No extensions are allowed on your drone. The drone must not exceed 1.5 kilogram, including power source and other parts. Last but not least, the drone can be programmed to perform autonomous tasks. The program can be implemented using a computer, laptop, Android phone, iPhone, or iPad devices. So there are in the drone competition, there are two categories, which is remote control drone challenge and autonomous drone challenge. So in remote control drone challenge, participant will manually navigate through a series of obstacles. And in autonomous drone challenge, participants will code and program their drones to autonomously navigate through the same obstacle course without any manual intervention. So for the scoring breakdown for remote control challenge is 30% of the total score, and for autonomous drone challenge is 70% of the total score. Okay, so this is the game field for the drone ch- challenge. Okay, as you can see from the left side of the box, it is the starting point. So there are five obstacles. So first obstacle is obstacle 1, and then you have to go through obstacle 2, pass through then obstacle 3, obstacle 4, and obstacle 5. After obstacles 5, in the right side, you have to land on the landing pad. So as you can see the right picture, this is the obstacle that you have to go through in. Okay, so this is the map dimension. Okay, so as you can see, the total length of the map are 360 cm, and the total width of the length is width of the length is 240 cm. So as you can see, there are five obstacle places on the map, and the obstacle height is, as you can see the right picture on the slide, the A for the height, and then B for the radius and the diameter of the diameter of the obstacle. So A is 135 cm, so your height will be 135 cm. Okay, and then the diameter of the obstacle is 60 cm, and the I will repeat again, the diameter of the the obstacle is 60 cm. Okay, so in remote control drone challenge category, so there we will provide a testing round for the participant. So participant will given 3 minutes to test and adjust their drone before the attempt. So attempt attempt testing. The testing period participants are allowed only one round to complete the obstacle course. Okay, for the task sequence, For the task sequence, the drone must take off from the designated area. As you can see, just now I showed the map, right? So the takeoff point, uh, sorry, the drone should take off from the designated area, which is the takeoff pad. Okay, the drone should fly through all the designated gates from obstacle 1 until obstacle 5, and then lastly it should land properly in the landing zone, which is the finish area. Okay, the judging criteria for remote control challenge. The total score is 30%, as I mentioned before. So points will be awarded based on the successful completion of the task. If no drones complete the task, scoring will be based on the highest number of checkpoint passes. Okay, so you can see the right table of the slide. So takeoff will be 5 points given, and then given for the gates are 20 points, and for the landing will be 5 points. So overall will be 30 points. Okay, for the autonomous round drone challenge. So this round is for the autonomously controlled by the drone. Autonomously control the drone by your controller. Okay, so the competition will consist of three rounds. First round is a trial round. Participants are given 10 minutes to adjust their drones and prepare for the task. Second round and third round is the judgment round. So participants are given 3 minutes to complete the task with unlimited attempts allowed. Okay, in 3 minutes you may complete the task with unlimited attempt allowed. Okay, so the best attempt from the two judgment round will be used for your final scoring. The drone must take off autonomously from the designated area, same as the previous control. So navigate autonomously through all the designated gate and land autonomously in the landing area or the finish area. Okay, the scoring system are quite different. So the performance in this round accounts for 70% of the total score. Points will be awarded based on the successful completion of the task. Participants can modify their code between attempts to improve performance. The best attempt will be used for your final scoring. So, in this task, the takeoff point is 10%, and the obstacle for 5 gates will be given 50 points. So, if you complete one gate, you will only get 10 points only. So, if you complete 3 gates, you will get 30 points. So, if you completed all, you will give you will get 50 points. Okay, and then final, you have to land it on the correct space. So if you land properly, you will get 10 points. So overall is 70 points to overall. Okay, so the additional rules and regulation. Okay, additional rules. Participant must raise their hand and seek permission for the referee in case of a mid-air collision. Okay, if any case of accident or crash, participant must raise their hands and seek permission from the referee. Participants are responsible for maintaining and operating their drones and ensuring their proper coding. Okay, so this qualification, if participant flying out of the bond, the drone flying out of the bonds or exceeding the maximum ceiling height, you will be disqualified. Or damaging the game field equipment or another participant drone, you will be disqualified. And another thing, if you are not following the referee instruction, you will be disqualified. Okay, these are the most common drone that you can get in the market right now. So Lightbee drone and DJI Tello drone. Unfortunately, the DJI Talon has stopped its production, but you can try to find any other drone than this. The drone should be, if you're finding any other drone than this, the drone should be controlled in piloting or, and autonomously. Okay, or if you wish to buy the Lightbee drone, you can we can help you to get it. The main So if you wish to buy the Lightbit drone, we can help you to get it because we are the main distributor for the Lightbit drone. If you purchase from us, we will give you a free training for the drone. So as I mentioned again, if you're going to buy a Lightbit drone, we can help you to get it because we are the main distributor for the Lightbit drone. If you purchase from us, we will give you a free training. Okay, now as you can see, this from the left of the picture, it's the Lightbee drone with the controller. So from the right picture is the DJI Tello drone. If students have learned the Scratch coding before, it's easier to use the Lightbee drone because it's quite similar. It's just the interface is changed, but all the function are quite similar. But for the DJI Tello, it's quite how do I say? Students couldn't understand the logic in the DJI Telodron because it do have a lot of logic. Okay, so if students are similar with the Scratch, you may do the you may get the Lightbee with drone. Okay, so now I would like to give a small briefing about how to use the autonomously autonomously Lightbee drone by using the Lightbee Go software. So I will preview some training for the Lightbee drone in this briefing. Okay, students. So this is the Lightbee Go interface. So you can see the interface are quite same with the Scratch software. Sorry. So you can see here there are motion, looks, sound, events, control, sensing, operators, variables, and my blocks. Okay, you can see the interface are quite same for the Lightbee drone. Okay, so what's the difference is the Lightbee wing extension here. So where you can get the Lightbee wing extension, you have to install the Lightbee Go software first. Okay, after install the Wing software, so you choose the extension here. So as you can see, there's a blue color drone button here. You click this one and then choose the Lightbee Wing, the second function. Okay, so in this Lightbee Wing extension, there are calibration, takeoff, and this one is the post hold means position hold, and auto landing, circle. Okay, the first one is calibration. This one is a calibration, takeoff, position hold, auto land, and circle. So when you use this code, the drone will be calibrated by itself. So this one is the takeoff code. If you use the post hold code, your drone will be hold the position for a while. And if you use the auto land code, your drone will be landed safely. And this code, the circle, will rotate your drone around 360 degrees. Okay, now this function is the set the height as 100 cm. As you know, it will set the height as 100 cm. So if your obstacle is quite high, around 200 cm, you just need to change here the value. Change it to 200 cm. Okay. Okay, now the fourth one, this one will no won't use because all the motor speed are constant. Okay, so this one, set the nose CW. CW means clockwise and CCW means counterclockwise. If you wish to, if you wish to rotate your drone to right position, so the rotation from right position straight to right will be in clockwise direction. Okay, so if you want to rotate your drone from front to left position, in the direction will be counterclockwise direction. So now if you wish to rotate your drone to right direction, you just need to click the clockwise here, and then how many degree do you want to rotate, and then you just put 90 degree or maybe 180 degree. So as you can see, there the limit is from 0 to 180 degree. So if you want to do 360 degree, you just need to place another block below it and change the value to 180. Okay, so this one will rotate your drone around 360 degree. Okay, now this function is to set your drone the direction. So which direction you want to move your drone. So you can set the direction to forward and backward here, and then you can set the speed. Okay, make sure the speed you have to set the maximum speed. I mean, you can see here, this one is calculating the distance per second. So distance per second, so you have to calculate the speed here. So this one, the maximum you can give is 60 cm per second. You shouldn't give more than 60 because your drone will move backward. If you put forward, it will turn around and move backward. Okay, so the maximum limit is 60 cm per second. You may put around 50 also can, or maybe 40. Okay. Okay, and then this one to control the left and right direction. Okay, so this one to control the left and right direction. So if you wish to go forward only, you don't want to go left or right, you just change the value here to 60 and make the left direction or the right direction to 0. Okay? Okay, now this one. Okay, these both functions are quite similar, but what's the add-on is the up and down direction. As you can see, the forward and left are same with the previous block, but this block is add up with up and down function. So if you want to draw, I mean, if you wish your drone to move upward, you just change here to 0 and your left and right direction to 0. So make sure you just put up direction to 50. Okay. Okay, so below is the extension tools. This one is the extension tool. If you want to get the extension model, you can use this Lampion mode. Okay, this one I just skip it. So this all of these three things are the extension tool. You need to buy it, the extension tool. Then only you can use with your Lightbee Wing drone. And then below is the variable: yaw angle, roll angle, pitch and angle, and flight voltage, flight height. So these are the variables. Okay, so I would like to teach, right now I would like to teach how to do a proper coding to move forward your drone. Okay, so first of all, just take it out everything. Okay, so first of all, I told you before, these software are quite similar with your Scratch software. So if you want to start anything in the Scratch, you have to go for the events. So in the events, you have to choose the when green flag click block. Okay, so you have to choose the when green flag click, because this block will start your entire coding. Okay, and then go to your Lightbee Wing blocks. Okay, first what we'll need to do is to calibrate your drone first. So when green flag click, you have to calibrate your drone. Okay, in the calibration, you need to give a time to do this function. If you didn't give a time, the calibration process will not work. So you need to give a time. So to give a time, you have to go to the control and choose the wait 1 second and change the value to 4 seconds. Okay, minimum you have to give 4 seconds. Okay, if you didn't give these times, your drone won't calibrate. Okay, so each task or each command you have to give a time to work. Okay, so now after 4 seconds, what's the next process is you have to what's the next process is to take off the drone. Okay, so take off, and then same, if you're going to take off your drone, you need to give a time to need to give a time to work this code. If not, the code won't be work. So takeoff should be same. You have to choose the in control. You have to choose the wait 1 second block and change the value to 4 seconds. Minimum you can give 4 seconds. Maximum you can give until 5 seconds. Okay, and then attach this block below here. Okay, as you can see, when green flag click, the drone will be calibrated first. So it will wait until 4 seconds. After that, it will take off. So take off, it have need to give a time for takeoff. Then only your drone will take off. Okay. After that, after takeoff, what can we do else? So we go to the Lightbee Wing block. Uh, we can set the height. So in case my obstacle in front is 200 cm. So I can set the height here to 200 cm. Okay, so I'm going to mention it again. So if you're putting a command, you need to give a time to work. If not, the command won't be work. So how? We need to go to the control again, choose the wait 1 second and change the value to 3 seconds to make the drone set the height set the the drone height to 200 cm. Okay, so we can give a 3 second to set the height. So make sure you have to give minimum 3 seconds to work. Okay, now I attach this block in this line. So now you can see when I click the green flag, okay, the drone will calibrate for 4 seconds. After calibrate, it will take off for 4 seconds. So and then it will set the height to 3 seconds. Okay, now my drone is already in 200 centimeter height. So now what I can do is I can move my drone forward towards the obstacle. So how? I need to go to the light B wing and then choose this one. Set forward direction speed as 10 cm per second, comma, left direction the speed as 10 cm per second. So now my part is my direction, I need to go forward only. I no need to go right or left direction. I want to go I mean the drone need to go front direction only. It shouldn't turn to right or left direction. So what can I do is I set the forward speed. Okay, I need to choose the forward first. Okay, set forward direction as how many cm? You can put 60 cm per second. Okay, so maximum is 60 cm per second. And left and right direction, I make it 0 because I need the drone go forward, not left or right direction. So I put here 0. Okay, so here you have to give a time to work the command also, but you have to see here properly. Okay, you have to look over here. It shows 60 cm per second. So 1 second it will move to 60 cm. So if I want to move the drone around 180 cm, how many seconds do I need? So I need 3 seconds to move my drone to 180 cm because 60 times 3 is 180 cm. So I go to the control and choose wait 1 second and change the value here to 3 seconds. Okay, so I'm giving an example again. If I want to move my drone to 120 cm, so what should I do? So I need to divide 120, maybe I can divide with 40 cm per second, or maybe I can divide by 3. So 40 divided by 3 is 120 divided by 3 is 40. So I change the speed value here to 40. So now my drone will move 120 cm forward. Okay. So if you want to move more than that, you can change. Okay, now what if I need to move my drone to 250 cm? So I change the value here only. Okay, so maximum speed is 60 cm per second, right? So 60 cm per second. So what if my drone I need to go 300 centimeter forward or 400 or 500 centimeter forward? So the speed limit is 60 cm per second, but I need to go move my drone to forward 480 centimeter. So what I can do is I can multiply the seconds. Okay, so 60 times 8 will be 480 seconds, right? So now it will move forward to 480 centimeter. Okay, so if you want to move to 300 centimeter, you just change your weight value. Okay, value here, not the speed. Okay, you just change here to 5 seconds. So now 5 times 60 will be 300. So your drone can move until 300 centimeter per second. Okay. Okay. So now after this, attach the block here. Okay. So my task is I need my drone to go move forward only, right? So after move forward, I need to, after move forward, it will go through the obstacle and it can be land on the landing pad. So how should I do? I just add the auto land blocks. Okay, in auto land blocks, I add this one. Okay, after auto land, all the code should stop. So what can I do is go to control, and choose the stop all blocks. Okay, now your block will, your drone will stop. After stop, your coding also will be ended. Okay, so I'm repeating from above. When you click the green flag, you can see there's the green flag here. So when you click the green flag, it will calibrate your drone for 4 seconds. After calibrate, it will take off your drone for 4 seconds. Okay, and then you can set the height to 200 cm per sec. 200 cm for 3 seconds. After 3 seconds, here this is the quite. Okay, after 3 seconds, the drone should move forward for 300 centimeter. So what I put is the direction speed is 60 cm per second and wait for 5 seconds, which means 5 times 60 will be 300 cm. Okay, after 300 cm, the drone will auto land. Okay, okay, and then I would like to teach another coding. Not another coding, like a safety emergency coding. Okay, what is a safety emergency coding? If in case when you are controlling your drone by pilot, okay, you can take it off. But when in case it collide or crash at the obstacle or crash on the people, so you need to emergency stop your drone, right? So what can you do is you can put a safety button. Example, you go to events, choose this one, when space key press. Okay, when space key press button. Okay, when space key press, this code will be, I will attach another code which is when space key press, I need to stop the drone. So what should I do is, what can I do is I choose the auto land block here. Okay, go to Lightbee Wing and choose the auto land. You can see when the space key press, it will auto land your drone. Okay, but you have to stop the coding also. Okay, so here when space key is pressed, the drone will be auto land and overall coding will be stopped. This is an emergency key button. Okay, so why do I choose a when? Why do I choose a space key? Why I can choose a lot of key in my keyboard. Example like right arrow, up arrow, down arrow, or any alphabet or number also can. But why I choose the space key? Because in your keyboard, the largest key and easy to identify key is your space key. So you are easy to identify when any crashes is happen. You can emergency, uh, your mind will straightforward press on the largest key on your keyboard. Okay, so it's easy to find and straightforward to press the key. Okay, so when this coding is run, keep running. If in case your drone going to collide or crash something, you just press your space key on your keyboard. It will stop the coding. As you can see, I click the green flag here. Okay, the code will turn highlight. Okay, now I would like to interrupt, which when the drone going to crash, I just press the space key. It will interrupt the code and stop all. So the highlight is gone now. Okay. So this is how this coding work. And if you want to learn more from us, you may get the drone and we will give you the extra training. Okay. Okay, so that's all from the Lightbee Wing software. Okay, so any question from you, or you may ask any question. If you have any doubts, you may ask now. Can you try a Okay, thank you so much. And I will share the YouTube link right now. I mean the YouTube link again in the group, and you can look forward the briefing again. Thank you.